Ever wondered how scientists predict climate trends or how economists forecast market behaviors? The secret lies in a statistical process known as regression analysis, a powerful tool used in machine learning and data science. Today, we will explore this intriguing concept step by step, ensuring that even a complete beginner can grasp its essence. In its simplest form, regression analysis is a statistical method that allows us to examine the relationship between two or more variables of interest. While there are many types of regression analysis, all of them perform the same basic function. They predict one variable based on the value of at least one other variable. Let's start from the very beginning. The first step in regression analysis is understanding the variables. In this method, we have two types of variables, dependent and independent. The dependent variable, often denoted as y, is the outcome or the variable we wish to predict or explain. On the other hand, the independent variable, often denoted as x, is the variable that we use to predict the value of the dependent variable. The next step is to gather data. This involves collecting data points for the variables under consideration. For instance, if we are trying to predict a person's weight, dependent variable, based on their height, independent variable, we would need to collect data on the weights and heights of a large number of individuals. Once we have our data, we can move on to constructing the regression model. This involves finding the line of best fit, or the line that best represents the data points on a scatter plot. This line is represented by the equation y equals sign a plus bx, where a is the y-intercept, b is the slope of the line, and x is the value of the independent variable. The slope b tells us how the dependent variable changes for each 1 unit change in the independent variable. With our regression model in hand, we can now make predictions. By plugging in specific values of the independent variable into the model's equation, we can predict the corresponding value of the dependent variable. For instance, using our height-weight example, if we know a person's height, we can predict their weight using our regression model. Finally, it's important to evaluate the accuracy of our regression model. We do this by looking at the residuals or the differences between the actual and predicted values of the dependent variable. A good regression model will have small residuals, indicating that it is accurately predicting the dependent variable. In summary, regression analysis is a powerful tool in machine learning that allows us to predict an outcome based on one or more variables. It involves understanding the variables, gathering data, constructing the regression model, making predictions, and evaluating the model's accuracy. Remember, the beauty of regression analysis lies not just in its predictive power, but also in its ability to reveal the relationships between variables. So, next time you're marveling at a weather prediction or a stock market forecast, remember the role of regression analysis in making these predictions possible. Full voiceover. Let's take a real-world example to understand regression analysis better. Suppose we want to predict the weather on a particular day. To do this, we can use factors such as humidity, precipitation, UV ray index, and more as independent variables. These are the variables we believe have an influence on our dependent variable, which in this case is the weather condition, whether it's sunny, cloudy, rainy, etc. By analyzing the relationship between these variables, we can predict the weather condition on a particular day. This is regression analysis in action, making our lives a little more predictable and manageable.